Steel beams dangled beside open platforms, workers riding wall-free elevators with nothing between them and a 100-foot drop. These lifts, meant to defy gravity, were misused, deadly, and shockingly essential. Why did builders accept machines so lethal that deaths were calculated into the cost of every new floor? The brutal reality behind these early skyscraper elevators reveals a forgotten chapter of progress far more dangerous than you have been told. So what made them keep risking everything? Workers stepped onto platforms that offered no protection, just a flat plank or steel plate suspended over the open shaft. There were no walls, no railings, and nothing to grip but the edge or a cold steel cable, sometimes slick with grease. The drop beneath them could stretch 10, 20, even 50 stories straight down. On these makeshift elevators, one wrong step meant a fall with no chance to recover. Iron workers, riggers, and laborers rode these lifts daily, their boots inches from the void, hauling themselves and their tools into the sky. Archival photographs from the early 1900s capture the reality. Men stood shoulder to shoulder on platforms barely wider than a dining table, the city sprawling far below. Eyewitness accounts describe the wind whipping through open shafts, jackets flapping as men braced themselves against sudden gusts. There was nothing to stop a misstep, a stumble, or a shift in balance. Some platforms had a single chain or rope strung waist-high, more a psychological comfort than a real barrier. The open edges meant every ascent was a gamble. Workers recalled looking down and seeing nothing but empty air between their feet and the street. Even the most experienced hands admitted to moments of vertigo. The platforms themselves were often slick with rain, ice, or spilled oil, adding to the risk. In the rush to finish a floor, men would crowd onto the lift, clutching beams, buckets, or each other, trusting the cable above and their own balance to keep them alive. No safety gates, no guardrails, no second chances. The exposed design made every ride a test of nerve. For those building the city's skyline, the line between progress and tragedy was measured in inches. The width of a platform, the grip on a cable, the empty space below. Steel beams, sacks of cement, and crates of bricks piled onto platforms never meant for such weight. Workers and rigger teams balanced these loads by instinct, not by measurement. There were no posted limits, no warning signs, just a rough idea of what might hold and what might not. Planks would flex under the combined mass, sometimes bowing so much that men hesitated to step on, waiting for the telltale groan of wood under strain. Archival photos reveal platforms stacked high, beams jutting out at odd angles, buckets teetering near the edge. The center of gravity shifted with every movement, and a single misjudged placement could send the whole load tilting dangerously. Riggers had to improvise, using whatever ropes, chains, or slings were at hand. They lashed steel together as best they could, but nothing prevented a heavy girder from rolling or a barrel from sliding as the elevator jerked upward. The platform might lurch as it passed a snag in the shaft or sway if the wind caught an exposed beam. Workers spoke of sudden shifts. One moment everything was steady, the next a load was sliding, men shouting, boots scrambling for footing. More than one crewman was swept off by a shifting beam or crushed as cargo toppled unexpectedly. These makeshift lifts turned every trip into a gamble. The absence of defined load limits meant operators relied on guesswork, sometimes packing on a few extra men or another stack of bricks to save time. The pressure to keep building upward left little room for caution. Each overloaded ascent strained the cables, the platform, and the nerves of everyone aboard. The chaos of loading and the constant threat of collapse became part of the daily routine, a silent risk accepted in the race to reach the sky. Speed was everything on a skyscraper job. Construction bosses pushed for faster lifts to keep steel and concrete moving skyward, and the numbers were staggering. Some of these open platforms shot up at 600 feet per minute, about 10 feet every second. That is 7 miles an hour, straight up, with nothing between the workers and the ground but a single cable. Veteran engineers from the era warned that these speeds turned every lift into a loaded gun. The faster the ascent, the more energy built up in the system. If a cable snapped or a brake failed, all that stored energy released at once, sending a platform and everyone on it into free fall. Unlike passenger elevators, which had been slowed and fitted with safety brakes by the early 1900s, construction hoists often skipped those precautions to save time and money. The result was a machine that could go from motionless to deadly in a heartbeat. At 600 feet per minute, a loaded platform could rise from street level to the 50th floor in under 5 minutes. But that same speed meant any mistake, an overloaded platform, a sudden shift in cargo, or a frayed cable, could turn a routine trip into a disaster. Engineers calculated the kinetic energy of a fully loaded platform at those speeds. A 5-ton load, moving at 10 feet per second, packed the punch of a runaway truck. If the cable failed, there was little to slow the fall. Primitive friction brakes, if installed at all, could barely grip the rails fast enough to make a difference. In real accidents, platforms sometimes dropped several floors before coming to a stop, if they stopped at all. Survivors described the sensation as a sudden lurch, a stomach-dropping plunge, and then either a crash or a merciful jolt if the brakes finally caught. The pressure to build higher and faster drowned out most safety concerns. Contractors boasted about record-setting speeds, measuring progress in floors per week. But the price for that speed was paid in risk. Workers learned to gauge the elevator's mood by the way it started, the hum of the motor, the tension in the cable. A slight shudder or a delay could mean trouble ahead. There were no alarms, no automatic shutoffs, just the hope that the cable would hold for one more run, and that the brakes, if present, would do their job when it mattered most. Speed made the job possible, but it also made every ride a gamble. The higher the velocity, the less time anyone had to react if something went wrong. For men riding those platforms, the numbers were not just statistics. They were the difference between getting home at the end of a shift or never coming down at all. A single rope, stretched taut above the platform, carried the weight of every man and every ton of steel. In the earliest days, that lifeline was nothing more than a thick hemp cable, fibers twisted together, strong enough in theory, but vulnerable to water, rot, and the slow grind of friction. Even after steel wire ropes replaced hemp in the late 19th century, the sense of security was thin. Steel cables promised more strength, yet they faced their own slow undoing. Every trip up and down bent the wires over pulleys, each cycle weakening the strands. Tiny breaks in the outer wires often went unnoticed, hidden beneath layers of grease and grit. With each load, the margin for error shrank. Inspections, if they happened at all, were rushed or superficial. There were no standardized rules for how often ropes should be checked or replaced. Some foremen trusted their eyes and a quick run of the hand along the cable, searching for frayed spots or broken wires. Others relied on gut feeling or the absence of visible disaster. In practice, cables stayed in service until someone noticed a problem, or until the worst happened. Trade journals from the early 1900s warned that a rope losing just 10% of its strands could lose half its strength, but warnings rarely translated to action on busy sites. No backup cable waited in reserve. Construction hoists commonly used a single rope or chain, unlike passenger elevators that might have 3 or 4. If that one cable failed, there was nothing to catch the platform. The Otis safety brake, invented in 1852, could lock a falling car in place. Construction hoists often skipped this safeguard. Adding a brake meant more time, more money, and more complexity. For builders racing the clock, those were luxuries they could do without. Some sites used primitive friction brakes, little more than a clamp or lever that pressed against the guide rails. These devices required constant adjustment and could fail if the platform moved too fast or if the operator hesitated for even a second. Weather, too, played its part. Moisture seeped into hemp ropes, swelling fibers, and hiding rot. Steel cables exposed to rain and wind rusted from the inside out. Lubrication helped, but only if applied regularly, a step often skipped in the rush of daily work. Workers sometimes noticed a cable humming or vibrating in a new way, a subtle warning that the inner wires were breaking down. Most ignored it, trusting that today would not be the day the rope gave out. The absence of reliable brakes meant that a snapped cable almost always led to tragedy. When a wire rope parted, the platform dropped with nothing to slow its fall. Survivors described the sickening moment when the tension vanished, replaced by silence, and then a rush of air. In rare cases, a friction brake might grab just enough to slow the descent, but more often, the outcome was fatal. Every ride depended on the hidden strength of a cable and the hope that its flaws would stay secret a little longer. The real danger was not always visible. A frayed core, a patch of rust, a brake left untested. The machinery that lifted men skyward held its own secrets, and those secrets could turn deadly in an instant. Wind sweeping through the unfinished skeleton of a skyscraper could turn an ordinary elevator ride into a battle for survival. High above the city streets, open platforms dangled from cables, exposed to every gust and squall. When a cold front rolled in, workers felt the lift begin to sway, sometimes tilting several feet off-center. The platform would creak and groan as it shifted, metal cables humming under the strain, the city spinning below. Even a moderate wind, 20 or 30 miles per hour, was enough to set the elevator in motion, swinging like a giant pendulum inside the elevator shaft or, on some jobs, in the open air between steel columns. Ice storms and freezing rain brought their own dangers. Ropes stiffened and platforms became slick, turning boots into skates. Workers huddled together, gripping whatever they could, as the elevator swung in wide arcs. Some remembered the sensation of being lifted off their feet as the platform reached the peak of its swing, only to slam back the other way when the wind shifted. There was no way to predict when a gust would hit or how far the car would move. Meteorological records from the early 1900s document wind speeds in New York regularly topping 40 miles per hour during winter storms, a force strong enough to set even the heaviest platforms in motion. On the Rockefeller Center site in February 1930, a sudden squall sent a loaded hoist platform swinging so violently that it struck the side of the building, scattering bricks and nearly throwing 2 men into the void. Incidents like this were not rare. Workers learned to brace themselves, knees bent, arms wrapped around cables or steel posts, waiting out the motion. Some platforms were seen tilting at angles so severe that tools and loose boards slid across the deck, clattering over the edge. The only thing keeping men aboard was their grip and their nerve. There were no wind sensors, no automatic shutoffs. The decision to move the platform rested with the men on board or the operator below, neither of whom could fully judge the conditions hundreds of feet above the street. If a load shifted while the elevator was swinging, the combined forces could tip the platform further or even snap the cable. In the worst weather, some crews refused to ride, but more often the job pressed on. Schedules did not pause for weather, and pay depended on progress. For the men who rode those platforms, the weather was an invisible hand, unpredictable and indifferent. Each gust could mean a sudden tilt, a lurch, or a terrifying moment when the ground seemed to disappear. The city's skyline grew upward, but every floor added meant another story exposed to the wind, a reminder that nature, not just machinery, decided who made it home at the end of the day. Operators arrived before dawn and stayed until the last load was hauled, clocking 12-hour shifts that blurred day into night. Most were hired straight from the labor pool, young, strong, and cheap, but with little training. Their job was simple in theory: to raise and lower the platform on command. In reality, it was a constant test of focus and nerve. Fatigue crept in as the hours dragged on, dulling reflexes and clouding judgment. Union logs from the period mention men nodding off at the winch, hands slipping from levers, or missing a signal in the haze of exhaustion. Mistakes became more likely as the workday stretched, but the pace never slowed. Communication between the men above and the operator below relied on a patchwork of hand signals and rope bells. There were no radios and no intercoms, just a series of tugs or gestures sometimes lost in the clatter of steel and the roar of engines. One bell meant up, two bells meant down, but every site had its own code, and new hires learned by watching and guessing. In the chaos of a busy job, signals were easily missed or misunderstood. Wind whistled through the shafts, muffling shouts. Gloves slick with oil slipped as men tried to signal from 50 stories up. Sometimes the operator would start the lift before everyone was aboard, or lower it while a worker was still stepping on. There were cases where a misread gesture sent the platform lurching upward and swept a man off his feet and into the void. Union records describe accidents blamed on operator error, a phrase that covered everything from honest mistakes to outright negligence. Some operators, half asleep after a double shift, pulled the lever the wrong way or failed to stop in time. Others, pressured by foremen to move faster, ignored weight limits or skipped safety checks. The men on the platform trusted the operator with their lives, but that trust was often misplaced. Inexperience, fatigue, and the absence of clear communication turned every ride into a gamble. The system depended on human senses, sight, sound, and touch, all strained to the limit by noise, weather, and exhaustion. A missed signal was all it took for disaster. In the aftermath, blame was easy to assign but hard to fix. The next day, another operator took the controls, another crew stepped onto the platform, and the cycle began again. For the men who built the skyline, the dangers were not just mechanical. They were written into every shift, every signal, every weary hand on the lever. Eugene Fay reported for work on a gray October morning in 1930, just another ironworker among hundreds on the Empire State Building. That day, a cable frayed under the weight of a loaded platform. Fay was riding up with two others when the rope gave way. The platform dropped without warning, slamming into the shaft's bottom. Fay was pronounced dead at Bellevue Hospital, his boots and lunch pail found amid the wreckage. His name appeared in a brief obituary, one of many lost in the city's daily churn. Patrick Griffin's story ended in March 1931. He had been hauling steel beams up to the 40th floor when the overloaded platform jerked sideways. A beam, stacked too close to the edge, shifted as the lift started. Griffin was struck in the chest and thrown backward. He died before the ambulance arrived, his body removed quietly while the site pressed on. The accident report listed crushed by falling material. James Murray was a rigger, known for his steady hands and quick jokes. In December 1930, he was guiding a load of concrete buckets when a sudden lurch sent the platform swinging. Murray lost his grip as the car tilted, falling more than 20 stories to the sidewalk below. The union sent flowers to his widow, but the job never paused. His death was noted in the minutes of Iron Workers Local 40, a single line among many. Samuel Lopez, a laborer from Brooklyn, died in June 1931. The elevator operator, exhausted after a double shift, misread a hand signal and started the platform before Lopez had both feet aboard. He slipped, catching the edge for a moment before falling. His pay envelope was sent home with a note that read, "Accident, elevator shaft." The fifth name was John Daly, a young apprentice. In April 1931, Daly was helping guide a platform loaded with bricks when a cable snapped overhead. The platform plunged 3 floors before a friction brake half-engaged, but not in time. Daly was crushed between the platform and the shaft wall. His father, also an iron worker, identified the body at the city morgue. Each of these men left behind families and stories that faded quickly from the headlines. Their deaths were recorded in obituaries, union logs, and accident reports, but on the job, the work continued. For every name written down, dozens more went unremarked. In the rush to build higher, each loss became another entry in the silent ledger of progress. In the world of early skyscraper construction, loss became routine, calculated, expected, and woven into the cost of doing business. Trade journals from the era printed it in black and white: 1 death per floor. The phrase appeared in a 1931 editorial not as a warning, but as a grim metric for project managers. Contractors and developers facing relentless deadlines and fierce competition treated fatalities as another line item on the budget sheet. Insurance payouts, compensation to families, and brief work stoppages were weighed against the cost of delays and safety upgrades. Memos circulated among management, tallying incidents and comparing them to projected profit. If a death meant a day's pause, but a safety device meant a week lost. The arithmetic often favored risk. Letters between site supervisors and company offices reveal a chilling pragmatism. One superintendent wrote, "We have lost 2 men this month. Progress remains on schedule." Another memo, preserved in a contractor's archive, calculated the average payout per fatality and compared it to the cost of installing enclosed cabs, finding the latter too expensive for a temporary hoist. The pressure to finish on time and under budget drove decisions from the top down. Safety upgrades were dismissed as unnecessary expense or slowing the job. Industry publications reinforced this logic. A 1929 issue of Engineering News Record described the risk of elevator work as an accepted hazard of the trade. Editorials debated the merits of new safety devices, often concluding that the cost outweighed the benefit for short-term projects. Builders, buoyed by insurance policies and the absence of strict regulation, saw little reason to change. The phrase 1 death per floor became shorthand for a system that measured human life in concrete, steel, and time saved. Workers understood their place in this calculation. Union minutes record bitter debates over whether to strike for better hoists or accept the dangers and keep earning a wage. Some men refused to ride the platforms after a fatal accident, only to be replaced by others willing to take the risk. The job went on, the building rose, and the losses were folded into the narrative of progress. In the end, the industry's moral arithmetic set the terms: death was part of the bargain, a cost absorbed and forgotten as soon as the next floor was poured. Elisha Otis spent his days in a Yonkers factory, surrounded by the steady clatter of machinery and the ever-present risk of falling loads. In 1852, he set out to solve a problem that haunted every building site. What happened if the hoisting rope snapped? Most workers knew the answer. There was nothing to stop the platform from plunging to the floor below. Otis designed a device that would change the equation. His invention, a simple but ingenious safety brake, used a wagon spring and ratchet system. If the rope broke, iron pawls would snap outward, catching the platform on the guide rails and bringing it to a halt. Otis was not content to let the idea speak for itself. In 1853, at the New York Crystal Palace exhibition, he climbed onto a raised platform high above the crowd. The only thing holding him up was a single rope. With a flourish, Otis called for the rope to be cut. An assistant swung an axe, slicing through the cord. The platform dropped a few inches, then stopped cold, caught by the safety brake. Otis turned to the stunned audience and called out, "All safe, gentlemen!" The demonstration made headlines and proved that vertical travel could be safe, even when the worst happened. Otis filed for a patent in 1852, and by 1857 his safety elevator was installed at the Hofbaut department store in New York. For the first time, people could ride above the 5th floor without dreading a deadly fall. The Otis brake was simple, reliable, and required no action from the operator. If the main rope failed, the brake engaged automatically, locking the platform in place. Despite the breakthrough, the construction industry was slow to embrace the safety brake. Passenger elevators in department stores and hotels started using Otis's device, but temporary hoists on building sites lagged behind. Contractors saw the brake as an unnecessary expense, especially for platforms that would be dismantled when the job was done. Installing the mechanism took extra time and money, and some builders argued that it would slow down the pace of construction. The logic was hard to escape. Every minute spent on safety was a minute lost on the schedule, and every dollar spent on equipment was a dollar off the bottom line. Otis's invention showed that a reliable solution existed as early as the 1850s. The technology to prevent deadly falls was available, proven, and already in use for paying customers. But on the skeletons of rising skyscrapers where speed and cost ruled, the safety brake was often left out of the plans. The gap between what was possible and what was practiced would haunt construction sites for decades to come. Pressure began to build from the ground up. Labor unions, already organizing for safer conditions in the wake of deadly falls, started circulating petitions and staging walkouts on major projects. Iron workers and elevator operators joined forces, bringing their demands to city officials and state labor boards. Meeting minutes from union locals in New York City record heated debates. Some members argued for an immediate strike, others for patient negotiation, but all agreed that riding open platforms was no longer acceptable. In 1913, union representatives appeared before the New York State Labor Committee, presenting accident tallies and survivor testimony. They spoke of men lost to snapped cables, of families left with nothing but a pay envelope and a funeral bill. Newspapers picked up the story, running editorials that called out the city's construction boom as a human cost too steep to ignore. Headlines: Like another builder falls, who pays the price? Landed on breakfast tables across the boroughs. Contractors pushed back hard. Letters to the Board of Aldermen warned that requiring enclosed cabs and automatic brakes would drive up costs by thousands of dollars per hoist. Builders argued that safety upgrades would slow construction by weeks, threatening jobs and profits. Some claimed that insurance already covered the risk, and that experienced crews could manage without new rules. But public pressure mounted. City hearings grew crowded, with union men filling the aisles and families of the dead standing in silent protest. By 1915, the city responded. New York's revised building code introduced a new requirement. All construction hoists on projects above a certain height had to use enclosed cabs and mechanical brakes. The language was clear: no more open platforms, no more single rope gambles. Inspectors gained authority to shut down non-compliant sites, and for the first time, contractors faced real penalties for ignoring safety. Union bulletins from that year celebrated the victory, calling it a hard-won safeguard for every man who rides the hoist. Municipal records show a sharp drop in elevator-related fatalities over the next decade. The fight was not over. Builders still found loopholes, and enforcement lagged. But the balance had shifted. Collective action backed by public outrage and the threat of legal force had finally turned cost arguments on their head. Safety was no longer a luxury. It was the law. Every modern skyline stands on safety standards written in blood. Today's construction sites enforce regulations that save lives, but around the world, 1 in 5 workplace deaths still happens in construction. Progress is never automatic. It is paid for, demanded, and defended. The lesson endures. When speed and profit outrun safety, it is workers who fall. We build upward, but only vigilance keeps us from repeating the same fatal mistakes. Thanks for watching. Share your thoughts below.